Imagine the entire universe squeezed into a point so small, yet so immensely powerful that it contained all the energy and matter that would eventually form everything we know today. This point was incredibly hot and dense. Temperatures and pressures beyond our wildest imaginations were present in this minuscule space. We call it a singularity, a term that signifies a point where our current understanding of physics breaks down. It's hard to grasp, but this is where our story begins. From this almost inconceivably small point, the vast and complex universe we inhabit today started its journey. About 13.8 billion years ago, something incredible happened. In a fraction of a second, the singularity began to expand. The singularity began to expand. This event, known as the Big Bang, marked the birth of our universe. This wasn't just an explosion in space, but an expansion of space itself. Space and time themselves were stretching and growing. Think of a balloon being inflated. As the balloon expands, every point on its surface moves away from every other point. The universe expanded like this balloon, only much faster and more dramatically. In the first few moments, it grew from smaller than an atom to larger than a galaxy. Everything we see around us, all the stars, planets and galaxies, originated from this single point. Over billions of years, matter coalesced to form the complex structures we observe today. The Big Bang wasn't just a bang, it was the birth of our universe. It set into motion the creation of everything we know, from the smallest particles to the largest galaxies, shaping the cosmos into the magnificent expanse we explore today.
In the first fraction of a second, the universe expanded at an astonishing rate. This period is called inflation. Imagine a grain of sand suddenly becoming the size of our solar system. That's how rapidly the universe grew during inflation. This rapid expansion smoothed out the early universe. It helps explain why our universe looks remarkably similar in all directions today. After inflation, the universe continued to expand, but at a slower pace. This expansion continues even today. As the universe expanded, it cooled, much like air escaping a tire. This cooling was crucial for the formation of everything we see around us.
As the universe cooled, energy began to transform into matter. This wasn't the complex matter we see around us, not yet. Instead, the universe was filled with tiny particles like protons, neutrons, and electrons. These particles are the basic building blocks of all matter. Think of these particles as the letters of the alphabet. They can combine in countless ways to form different words, sentences, and stories. In the early universe, these particles were too hot and energetic to combine. They moved at incredible speeds, constantly colliding with each other.
About 380,000 years after the Big Bang, the universe cooled enough for atoms to form. Protons and neutrons combined to form the nuclei of atoms. Electrons then joined these nuclei, creating the first atoms. This period is called recombination. It marked a significant change in the universe. Before recombination, the universe was opaque. Light couldn't travel freely because it constantly bumped into free electrons. After recombination, with electrons now bound to atoms, the universe became transparent. Light could finally travel freely across space. This first light is still detectable today as the cosmic microwave background radiation.
Section 5. From gas clouds to galaxies. The early universe, even after recombination, was not completely smooth. There were tiny variations in density, like ripples in a pond. Gravity, the force that makes objects attract each other, amplified these variations. Regions with slightly more matter began to pull in surrounding gas. These clumps of gas became denser and denser over millions of years. Eventually, they became so dense and hot that nuclear fusion began. This is the process where atoms fuse together, releasing tremendous energy. The first stars were born. These stars were grouped together in collections that would eventually become galaxies.
Section 6. Islands in the expanding universe. Galaxies are vast collections of stars, gas, dust, and planets. They are not randomly scattered throughout space. Instead, they are arranged in a vast cosmic web like a giant spiderweb. The threads of this web are made of galaxies and clusters of galaxies. Between these threads are vast voids, relatively empty regions of space. This web-like structure of the universe is still evolving today. Galaxies are constantly moving, interacting with each other, and sometimes even colliding.
Section 7, Echoes of the Big Bang. In this section, we delve into the profound remnants of the universe's birth. We know about the Big Bang and the early universe thanks to several crucial observations. These observations have been made possible through the relentless efforts of scientists and the advanced technology of our telescopes and satellites. One of the most important is the cosmic microwave background, or CMB radiation. This radiation is a faint glow that fills the universe and is a critical piece of evidence for the Big Bang theory. This faint afterglow of the Big Bang is like a baby picture of the universe. It provides us with a snapshot of the universe when it was just 380,000 years old, allowing us to understand its early conditions and subsequent evolution. Another key observation is the redshift of distant galaxies. This phenomenon was first discovered by Edwin Hubble and has since been a cornerstone in our understanding of the universe's expansion. Redshift is the stretching of light waves as they travel through space. When we observe distant galaxies, their light appears redder than it should be, indicating that they are moving away from us. It tells us that the universe is expanding. This expansion is not just a simple movement, but a stretching of space itself, causing galaxies to move apart from each other. The farther away a galaxy is, the faster it seems to be moving away from us. This relationship, known as Hubble's law, provides strong evidence for the Big Bang theory and the continuous expansion of the universe. This observation supports the idea of an expanding universe that originated from a single point. The Big Bang theory suggests that the universe began as an incredibly hot and dense point approximately 13.8 billion years ago and has been expanding ever since, leading to the vast cosmos we observe today.
Section 8. Unraveling the Cosmic Puzzle. While the Big Bang Theory explains a lot about our universe, it doesn't answer everything. There are still many mysteries that puzzle cosmologists. One of the biggest mysteries is dark matter. This invisible substance makes up a large portion of the universe's mass. We can't see dark matter directly, but we know it exists because of its gravitational effects on visible matter. Another mystery is dark energy. This force seems to be accelerating the expansion of the universe. Scientists are still trying to understand what dark energy is and how it works.
Section 9. The Universe. A never-ending story. It is a tale that stretches across the vastness of time and space, a narrative that has no beginning and no end, only transformations and evolutions. The Big Bang Theory is the best explanation we have for the origin and evolution of our universe. This monumental event, occurring approximately 13.8 billion years ago, marked the birth of everything we know. It tells a story of an incredibly hot, dense state that rapidly expanded and cooled, eventually giving rise to the stars, galaxies, and planets we see today. From this singularity, the universe has been expanding ever since, creating a cosmic tapestry of unimaginable scale and beauty. While we have learned a great deal, the universe is full of mysteries. Dark matter and dark energy, which make up about 95% of the universe, remain largely unknown. These enigmatic components challenge our understanding and drive our quest for knowledge. The study of the universe is a journey of discovery. It is a path filled with questions and the relentless pursuit of answers. Astronomers and scientists dedicate their lives to unraveling the secrets of the cosmos using advanced technology and innovative methods. Every new observation, every new theory brings us closer to understanding our place in the cosmos. The discovery of exoplanets, the detection of gravitational waves, and the mapping of cosmic microwave background radiation are just a few milestones in our ongoing exploration. The Big Bang Theory is not just a scientific concept, it is a reminder of the awe-inspiring nature of the universe and the power of human curiosity. It encourages us to look up at the night sky with wonder and to continue seeking answers to the profound questions about our existence and the universe we inhabit. The story of the universe is indeed never ending, and our journey to understand it is just beginning.